Hello, grade 10s. So this is the video for Unit 4, Lesson 1. So this is the very first lesson of our next unit that we're starting. And Unit 4 is all about radicals and powers, okay? So a radical means anything with this symbol over it. Okay, so that's that square root symbol. Or sometimes if, say, for example, we put a 3 right there, that would be a cube root symbol. Or if we put a 4 right there, that would be a fourth root symbol. Okay, but regardless, that symbol right there is called a radical. Okay, there are perfect radicals. So for example, perfect squares. Perfect squares would be like what we've talked about, 1, 4, 9, 16, etc. Okay, then of course there's perfect cubes. Now perfect cubes, if we were looking at the poster in my room, the first perfect cube would be 8 because that's 2 times 2 times 2. The next one would be 27 because that's 3 times 3 times 3. And I actually gave you guys a table right here of all of the perfect squares. So these are These are perfect squares. Okay, so again, 1, 4, 9, 16. And then if you just look over to the left, that's its square root, right? So square root of 16 is 4. These are a list of all the perfect cubes. Again, the perfect cube of 8. 8 is a perfect cube, and if we look all the way to the left, its cube root is 2. Okay, I've also included perfect fourths. Okay, so 16, for example, we get 16 by going 2 to the 4, or 2 times 2 times 2 times 2, right? So again, if you just look all the way over to the left, you'd find out what the fourth root of 16 is. Okay, so that's how you use this table, and we are going to be using this table quite a bit for this lesson. And I've also included perfect fifths as well. That's rare that we use those, but we do sometimes. Okay, so we need to know perfect squares, perfect cubes, perfect fourths, and perfect fifths. Today we're going to be dealing with imperfect radicals. So for example, 15. 15 is not a perfect square. It's not a perfect cube. It's not a perfect fourth. You'll see 15 nowhere in this list. Okay, so we're going to deal with radicals of imperfect numbers today. So for example, here it says, write the following entire radicals. So this is called an entire radical because it's not simplified yet. It's in its entire form, or sometimes the textbook or I might refer to it as a whole radical because it's not simplified or broken down yet. Okay, so we're going to take this whole radical or entire radical and we're going to write it in its simplest form. Sometimes I'll also use mixed form. Okay, so this is what we do. I'm going to write the steps up here where there's some space. Step number 1 is we rewrite the imperfect number, right? So for example, the first example there was 24. So we would rewrite 24, or the imperfect number, as 2 factors. So last unit, in Unit 3, we talked a lot about factors. The factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6, etc. Right? So we're going to rewrite the imperfect number as 2 factors, but one factor, sorry, let me erase that. But one factor has to be perfect. Okay, and then we will simplify. So we are going to rewrite 24 as 2 factors, but one factor has to be perfect. Okay. So let's think of the ways to multiply for 24, because I have to rewrite 24 as 2 factors. So 1 and 24, and it will never be that option. Ever, 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 ever. 2 and 12, 3 and 8, and finally 4 and 6. Okay, So for this question here, I have to pick one of these three groups, 2 and 12, 3 and 8, and 4 and 6. But the steps above said that I have to pick the option that has a perfect factor in it. Meaning, because there's no number in that little nook, there's actually a 2 there. Okay, and so because there's a 2 there, this is a square root. We want the square root of 24. So when I am looking at these three options here, I have to pick the option that contains a perfect square because I want the square root of 24. So 2 is not a perfect square, 12 is not a perfect square, 3 is not, 4 is not, or sorry, 8 is not. But here, this is the option I'm going to choose because 4 is a perfect square. If you go back up here, there is a 4 in my perfect square list. Okay, so I'm going to rewrite 24. Whoops. I'm going to rewrite 24. Sorry, I got to get rid of that. As 4 times 6. Okay, so all I've done is rewritten 24 as 4 times 6, and the next step said simplify. So because 4 is a perfect square, we ask ourselves, what's the square root of 4? Well, the square root of 4 is 2, and so that comes out of the radical. And then we cannot take the square root of 6. 6 is not a perfect square, so he just stays underneath the radical, and that is the simplified version.
Why is he trapped, Mom?
Sorry. My son just walked in. Sorry, guys. Okay, honey, I'm just teaching a lesson, okay? 1 second. Okay, you can just listen. Okay, so now we have to think of a way to break down 80. What times what can give me 80? But because I want the square root of 80, I have to pick an option that comes from these numbers here. So what you do is you take your calculator and you start fairly high up, maybe like 64. Can 64 go into 80? 64 times something give you 80? No way. 49 times something give you 80? No way. 36 times something give you 80? No, and all you have to do is go 80 divided by 36 on your calculator. It gives you a decimal, so you know that that's no good. 80 divided by 25? Nope, it gives you a decimal. 80 divided by 16? Bingo! We can divide 80 by 16 perfectly. So what we do is we go back. Okay, we go back down here and we rewrite 80 as 6. Honey, you're bumping me. You're bumping me. 16 times 5. Okay, so we rewrite it as 16 times 5. Now to simplify, I chose 16 because it's a perfect square. So the square root of 16 is 4. That pops out of the radical, and that 5 cannot be simplified anymore. There's no perfect square root of 5, so it stays underneath the radical, and we're done. Okay, square root of 30. If I think of all of the ways that multiply for 30, 1 times 30, 2 times 10, no, oh my God, what? I'm crazy. 2 times 15, 3 times 10, and 5 times 6. Those are the only ways to multiply for 30. But if we compare all of these numbers here with the list of perfect squares right here, none of those numbers in this list here are perfect squares. So there is no possible way to simplify 30. So we're done. There's nothing we can do. 30 is technically in its simplified form already. We can't break it down anymore. Okay, so this next one, you'll notice the 3. So that means I want the cube root of 144. So I have to, same thing, break down 144 into something times something. What times what gives me 144. But because I'm taking the cube root, when I think of the two numbers that multiply for 144, one of them has to now come from these numbers, the perfect cube numbers. So again, if it's 144, we'll start with dividing it by 125. Well, if 144 divided by 125 does not work. 144 divided by 64, nope, you get a decimal. 144 divided by 27, nope, you get a decimal. So we're really, really hoping that 8 works because we're about to run out of options. And if you go 144 divided by 8, bingo, it works perfectly. 8 times 18. Okay? And some of you may be asking, why did I start at 125? Well, I know 216 won't work because 216 could never go into 144. So I start with the first number that's below 144. And I work my way down, and I found out it's 8 times 18. So I go back here, and I go 8 times 18. So now I simplify. Because I chose 8, I know that's a perfect cube. So I know there's a cube root of 8. So you go back here, you look all the way to the left, the cube root of 8 is 2. So we can pop that out. So we have a big fat 2 out front. And then we rewrite that 18 underneath there because 18 can't be broken down anymore. There's no perfect cubes that exist inside 18. We've simplified it. All right, same thing, cube root of 108. So I want to rewrite 108 as something times something. But again, because it's the cube root, one of the options I pick has to come from this list of perfect cubes. So again, if it's 108, I'll start at 64. Can 108 be divided by 64 perfectly? If you go 108 divided by 64, nope, you'll get a decimal. Can we go 108 divided by 27? So try that on your calculator and you find out it works perfectly. You get 4. 108 divided by 27 is 4. So because you get a nice perfect number there, no decimal, you know that 27 times 4 is your option. Those two numbers equal 108, and 27 is a perfect cube. So now we just simplify. Well, what is the cube root of 27? We go back here, cube root of 27, go all the way to the left, it's 3, because 3 times 3 times 3 is 27. And then that 4 cannot be simplified anymore. He just keeps hanging out under the radical. Okay, now we're on to fourth roots. So hopefully you've caught on by now. If I'm doing the fourth root, I have to think of two numbers that multiply for 162. But when I think of the two numbers that multiply for 162, they now have to come from my perfect 4 column. Okay, so what was the number I was trying to multiply for again? 162. So you take 162 and you'll divide it by the first number that's below 162, 81. 162 divided by 81 is 2 on the nose. So bingo, we found it right away. 81 times 2. So we go back here and go 81 times 2. The fourth root of 81 is 3. So that gets popped out. And then that 2 just stays underneath because we can't simplify him anymore. Always, you guys, don't forget to write this number. Whatever the number is, you always have to make sure you write it in your answer. Unless it's a square root, the 2, you don't need to write the 2. But a 3 and a 4 and a 5, you have to write it. Okay, couple more. Now I want 128. So again, it's the fourth root. So I have to think of two numbers that multiply for 128. So I'm just rewriting this as something times something. So you go up here in your fourth roots. And if I want to multiply for 128, I'm going to start at the first number that's below that, which would be 81 again. If I divide by 81, nope, I get a decimal. If I take it 128, it was 128, right? Yeah, if I take 128 and divide by 16, I have a feeling that's going to work. You get 8. So bingo, 16 times 8 is what we're going to choose. So 16 times 8. Now, the fourth root of 16 is 2, because 2 times 2 times 2 times 2 is 16. So he comes out, and then that 8 can't be broken down. There is no fourth root of 8. We're done. And this is the only example here with a fifth root. So we want to rewrite 96 as something times something that equals 96. But now we're going to pick one of the numbers has to come from our fifth column. So I want to multiply for a 96. Whoops. So you start with the first number below 96, which is 32. So it has to be that one. 96 divided by 32 is 3. So we got it. okay? So 32 times 3. So 32 times 3 is 96, and you have to now simplify. What's the fifth root of 32? You go back up here, you go all the way to the left, and you'll see it's at 2. So 2 is the answer, that comes out. And then that 3 just stays underneath. And we're done. Okay, these questions here are just the opposite. So these go way faster, actually. So it's like I give you the answer, I give you the mixed form or the simplified form, and you have to return it to its entire form. So all we do here is, well, this is a square root because there's no number there, right? So square root. Now, all you do is bring that 4 back underneath and square it again. Because when we took it out, we square rooted it. So when we send it back in, we square it. Okay? And then 4 squared is 16 times 3, and 16 times 3 is 48. And we're done. That was the original question. It's kind of like factoring. We're going backwards. What was the original question? Okay, so now it's a cube root. So when we send that 3 back in, we cube it. And then that 2 is already there. The cube root of 20, sorry, not the cube root. 3 cubed is 27, so it's 27 times 2. So the original question was 54, and don't forget that there's a little 3 inside. I will take half a mark off if you forget that 3. Okay, here it's a square root again, so we know when we send that 7 back in, we square it. So it must have been a 49 in order for a 7 to have popped out. It was a 49 underneath times 3. And so that is 147, square root of 147. These go fast, hey? Okay, this one, we send it back in because it was the cube root. We're going to cube it when we send it back underneath. 2 cubed is 8. So it's 8 times 4. And 8 times 4 is 32. And don't forget, the 3 should actually be at every step. I forgot that there too. My bad. Okay, fifth root. Same thing. When we send it back under, we send that 2 back in, but we put it to the 5 now, and then times that 3. 2 times 2 times 2 times 2 times 2 is 32 times 3, and 32 times 3 is 96. Again, make sure you slide that 5 in the nook there every time. And last but not least, send that 2 back in to the power of 5 because it was the fifth root. 2 to the power of 5 is 32. And then it becomes 64. And then slide that 5 in each step. Okay, so obviously those ones go way faster. You just send it back in and put the power back on it. These ones take a little bit longer because you have to think of the 2 correct numbers. Okay. The assignment is here. All right, you can give that a start. And you can expect a bell work on this question when you get back. Good luck.